Alright, in this video I am just doing an example on how to use the method of joints to solve a truss problem in statics. So here we have our truss. It's pretty simple. There's just one externally applied force here, and it's simply supported. All of the members in the truss are 1 meter long, so that means all of these triangles are going to be equilateral triangles, so every angle you see is going to be 60 degrees. Okay, so the first thing that we need to do for using method of joints is to draw our free body diagram of the entire structure. And now we can find the reaction forces here at A and E. So if we take the sum of forces in the x direction, well, that's just AX, and that has to be equal to 0, so AX is equal to 0. If we take the sum of forces in the y direction, we know that we have to have negative 200 newtons, that's that applied force down, plus AY plus EY, and that all has to be equal to 0. And then we have to come back to that, so we'll take a sum of moments. We'll pick some positive sense, and let's take the sum of moments about A. Okay, so when we take the sum of moments about A, we know that's going to be equal to 0, so we have, this will be negative sense, so we have negative 200 times 1.5 meters, that's 200 newtons times 1.5 newtons, plus the moment caused by this guy, so it'll be plus EY times 2 meters. Alright, that's all equal to 0. Then we just rearrange for EY, and we'll get EY is equal to, this is 200 times 1.5, so that is, that's 300 Newton meters over 2 meters, and that's going to give us 150 newtons. Then bringing this back in here, we just have to sum up to 200 using our sum of forces in the y direction, so we're going to find that AY is equal to 50 newtons, and these guys are both pointing up. Alright, so now the next thing that we need to do is we need to draw a free body diagram for each of the joints. Alright, so now we have all of the free body diagrams for each joint. I've drawn all of the unknown forces, which are all the internal forces in the members themselves. I've drawn them all in tension, so they're always pulling away from the point. Notice if, for example, member AB, if it's in tension at A, it's pulling away from A. It's also pulling away from B. That's if it's in tension somewhere in the rod, it's in tension everywhere in the rod. The reason we do this is just a sign convention, so when we're solving for the magnitudes of these forces, if we get it to be a positive force, that we know that it is actually in tension, and if we find that it's a negative magnitude, then we just know that it's the member is actually in compression. Alright, so let's go ahead and let's start solving these one by one, and we have to start with one that has a maximum of 2 unknowns, so we can just start with joint A here. Okay, so we'll start with the sum of forces in the y direction, and we do that because we already know something in the y direction. So we have 50 newtons going up, and then we have plus AB sine 60, and that all has to be equal to 0. So if we just rearrange for AB, we get AB is equal to negative 50 over 0.866. That's just the sine of 60. And when you punch that in your calculator, you're going to find that the force, the internal force in AB is negative 57, let's say 0.7 newtons. So that negative sign means that this is in compression, and we'll just indicate that with a C in brackets just to keep things straight. Okay, so now we'll take the sum of forces in the x direction. So sum of forces in the x direction, and we get well, we know that we have this negative 57.7 newtons, so it's pointing this way actually. So in the x direction, it's the negative component. So we have negative, there we go, negative 57.7 times cos of 60, plus we have AB, and that's this member is entirely, it's all of the internal force will be entirely oriented in the x direction, and that's equal to 0. So if we just have cos 60 times 57.7, cos 60 is just 0.5, so we're going to find out that, oh sorry, this is AC. What am I doing? There we go. Okay, AC. Alright, so AC, we just reorganize that, and we're going to find that this is equal to 28.85 newtons. This number is positive, so we know that this is actually in tension, and that's exactly what we want. Now, something that might be worthwhile doing is, as we progress, now that we know that something is in compression, we know that AB is in compression, I would suggest that you come back and you switch the arrows here. You know, you don't have to. You might find that you're doing it a slightly different way in your in your exams and things, but I just like to keep track of which way we're actually going. Alright, so now when we want to solve for B next, let's grab the free body diagram for B. Okay, so we're going to move this in. Now we know that AB is in compression and it has a magnitude of 57.7 newtons, so we already have the sense here properly, so we can actually, instead of writing AB, what we can do is we can just write 57.7 newtons. Okay, so let's take the sum of forces in the y direction first. So we'll have 57.7 times sine of 60, and then we'll subtract out BC times the sine of 60, right? Because this is also on a 60-degree angle because of all of our equilateral triangles. That's equal to 0. What we can do is we can actually just divide out the sine of 60 from both sides, bring the BC over, and so we're going to find that BC is actually going to equal positive 57.7 newtons. And again, this is a positive value, so that means we're in tension. If we analyze this for 1 second, we can look at this point and we see that there's this y component from this guy pointing up, so it would give it the tendency to want to translate up. So just looking at this is the only other component, or this is the only other force of the y component, so it has to be pulling down to counteract that, so we're not getting any of that translation for this particle basically. So that's something, a quick check you can usually do to make sure if these numbers are making sense. Okay, so let's take the sum of forces in the x direction now. So sum of forces in the x direction for joint B, we have 57.7 times cos of 60, that's 60, plus, and we're going to add this because they're both going into the right hand in the positive x direction, so we have plus BC, so this will be 57.7 times cos of 60, and then we also have plus BD, and that's all equal to 0. Okay, so when we add those all together, so cos 60 is 0.5, so 0.5 times 57.7 times 2 is just going to equal, and we'll bring it to the other side, so we'll get BD is equal to negative 57.